8th grade math, test 27 study guide. Number 1 asks us how we can write 8 to the 27th power as a product of powers. Well, here's an example of product of powers. Product of powers means you have powers, meaning a base and an exponent, and you're multiplying them, that's the word product, and the base is the same number. So when that happens, what we can do is we take these two numbers and we copy them and we add the exponents. And that's how it can be written as a product of powers. So another example of this, we could have 8 to the 15th times 8 to the 12th, which would also equal 8 to the 27th. And that would be a situation where we multiply the two powers with the same base and add the exponents. So the only answer that can work for 1 is A. Alright, so number 2. We have negative 3 to the negative 4th power, and since there's no multiplying or dividing to do with these numbers, in other words, we're basically finished, but we still have a negative, that's when we flip it. Remember, flip at the end, use your properties or your shortcuts first, and then if you still have a negative exponent, then you flip. Now, this negative here doesn't mean flip anything. This means you have a negative number. This negative in the exponent doesn't mean you have a negative number. It means you need to flip it. These two are actually the exact same number. This one's a little more simplified than this one. So, negative exponent means flip it. Now we're going to deal with the exponent. I have negative 3 4 times. That looks like this. Remember, when you have an even number of negatives, that's a positive answer. If I had an odd number of negative signs, that would be a negative answer. So this is basically 9 times 9, which is 81. I have 1 over 81. Problem 3, I'm going to divide these two powers. They have the same base. The shortcut for dividing powers with the same base is to copy the base, copy the 2, and subtract the exponents. 4 minus 1. Remember, there's a 1 right here. So, 4 take away 1 is 3. 2 to the 3rd is 8. Number 4, multiplying powers by the same base, like we talked about in problem number 1. Copy the base, add the two exponents, and then simplify. If I have negative 2 8 times, remember that's an even number of negatives, so that's going to be a positive answer. And I go 8 times 8 times 8 times 8. In other words, if I were to take 4 8s, that's, excuse me, I said that incorrectly. Negative 2 times negative 2 times negative 2, I have that 8 times, not 8 times. So if I were to take negative 2 4 times, negative 2 times negative 2 is 4, and then 4 times 4 is 16. So if I have 8 of them, that's like 16 times 16. That's how you can shorten it up, which gives you 256. And if what I just said doesn't make sense, then just go ahead and multiply 2 to itself 8 times. You're going to get 256 either way. Okay, so now we have this long equation here. And we're going to do the rule for subtraction first. You see I did add the opposite here and add the opposite here. Now, I can distribute and combine like terms. That always works. However, I feel it's a little bit easier if you add these two together first. Negative 2x and negative 5x is negative 7x. Now I'm going to distribute. 4 times 3 is 12. 4 times negative 7x is negative 28x. 7 times positive 4 is 28x. 7 times 2 is 14. Now I'm going to go ahead and combine like terms. Remember, I'm not doing the opposite of negative 28 because they're on the same side. I only do opposite when I'm moving it to the other side. So when they're on the same side, you do exactly what you see, not inverse operations. So I add negative 28 and 28, but those are opposites. They actually cancel out. And I see this is a true equation. 26 equals 26. When the variable cancels out, and we're solving an equation. Remember, this is not a system. We don't have two equations. We have one. Then our solution here, the answer to this, is all real numbers. That's how we say that. In other words, everything's an answer. That was, remember in class when I did the magic trick and I made you guess the answer before you even knew it? That this is those type of questions. Okay? So again, what happened is the variables cancel out. We have a true equation. Normally we would say infinitely many, right? But that's for a system. Now when it's just one equation, we say all real numbers, everything's an answer. These are called identities. When it's not a system, when it's one equation, it's an identity. But the solution is all real numbers. Okay, now we're solving an equation again. And we're going to do our rule for subtraction. Add the opposite here. Negative minus 7g is the same as plus negative 7g. Combine my like terms. I add my two g's. Opposite teams mean subtract. Positives have more, so 9g and negative 7g equals 2g. Copy my plus 8, copy my equal sign, and copy the rest. This side's already simplified. Now I'm going to stop right there, because this one, unlike this one up here, I can see that, and actually, instead of saying infinitely many solutions, this is not a system either. Actually, that's incorrect. And I know it says that on our answer key. That's actually incorrect. It should say all real numbers, which is technically infinitely many solutions. So unless the direction says how many solutions, which it does, I'm wrong. The directions say tell whether the equation has infinitely many solutions. Okay, I should have read the directions. So actually that was right. What's the solution? The solution's all real numbers, but that's not what the question was asking us. The question was asking us, does this have infinitely many, or does it have no solutions? So that's why the answer is infinitely many. Sorry about that. Got to read the directions, right, before we do those problems. But anyways, I was able to stop early, right, because I can see that these two are the same and these two are the same. I don't need to continue on until I make it look like this, until the variable cancels out. When I see I have the same thing on both sides, I can stop. I know it's an identity. I know it has the solution is all real numbers. But because the directions asked me this time, does it have infinitely many or no solutions? That's why my answer is this one this time. Alright, so number 7, we've got to take a look at the graph. So it looks like we have a proportional graph here. We're on the x-axis. We have hours, time in hours, and on the y-axis we have distance. So we're dealing with the distance formula here. Okay, and it says which statement is true. Alright, so A says this: to find Greg's rate of speed, divide the total number of hours driven by the total distance. Okay, so, well, we know that distance equals rate times time. Distance equals rate times time. We have to memorize that, right? Okay, so rate is speed. So if distance equals rate times time, and they say to find Greg's rate of speed, or R, to find R, how do we find R? We need to isolate R. How do I isolate R? Next to means times. How do I undo times? Remember, when we move it, we do inverse operations. So rate is found by taking distance and dividing it by time. So for A, they say you can get rate by dividing hours, which is time, by distance. That's not true. You have to divide distance by time, not time by distance. So A doesn't work. B says this. Okay. B says to find Greg's rate of speed, multiply. So they're saying rate equals multiply distance and time. Well, I can see here it's not multiplying, it's division. So B doesn't work. C says this: Greg is traveling 60 miles per hour. Okay, well here's hours, here's 1, and up here is distance. No, that's not 60 miles per hour. If you look on your graph, I know it's hard to see on the video, but look on your paper, and it's actually 20 miles per hour. That's why the answer is D for this one. So for number 8, we got to look at the graph again. Number 8, we got to write the equation. I can see this line hits the y-axis right there at -2, so my y-intercept has to be -2. Now I'm going to take 2 points on the lattices, okay? Here's a point right here at -2. I'm going to go up 1, 2, 3, 4, 5, and over 1, so there's a slope of 5. Or I can go from this point up 5 over 1. Or I could even go from here up 10 over 2, because 10 over 2 also equals 5. It doesn't matter how I do it, I always get a slope of 5. So I just use my graph, I count it, I make sure to see whether it's a positive or a negative slope, and then I write my equation. Slope goes in front of x, y-intercept goes by itself, it's y equals mx plus b. Alright, so number 9. It says Ty is solving a system of linear equations algebraically, and he concludes that there is no solution. Okay, so which of these has no solution? Well, we already learned no solution means the variables have to cancel out, so forget about B and D. And we learned that no solution means you have two numbers that are not the same, so the answer has to be C. Number 10, looks like we're solving the system, and both equations already have a variable isolated, so I just plug this into the other one where the y goes. Substitute that where the y goes because the y is isolated. Get my variables on one side. Remember, I usually distribute and combine like terms first, right? But that's already done for me on both sides. Both sides are already simplified. So now I'll get my variables on one side. It's just less complicated to get the variables, the letters together first before you try to move the numbers, okay? So get your variables on one side first. Now we're going to isolate the variable, work farthest away. Again, when we're moving stuff, we do inverse operations. Divide both sides by 3, and negative divided by positive is always negative. So I know that where these two lines intersect, or the solution to this system, the x is negative 3, but now I have to get the y. So what I do, if x is negative 3, I take one of the other two equations, it doesn't matter which one, and I plug the x in, which is negative 3, where the x goes. So I substitute again. Remember, you substitute twice, because there's two letters we're getting, or two variables, or a pair of coordinates. Pair means two. Plug it in, simplify, and I see my y is negative 12. These two lines are going to intersect at negative 3, negative 12. Or another way to say that is, the solution to the system is negative 3, negative 12. So we're on problem 11 now. We have another system of equations that we're going to solve. I'm going to figure out where these two lines intersect each other, or find the solution to the system by substituting. My y is isolated, so I'm going to take this and plug it into the other equation right where the y is. So I'm going to write that in parentheses, because if there was a coefficient or a number in front, I would have to distribute. But since there is not, I can just go ahead and add these. How do I simplify this? Distribute, but I don't need to, because there's no number right in front of that. I can't do my root for subtraction, and I have x and negative x. Well, x and negative x, those are opposites, they cross out, so what I'm left with is that. And when I have a system or two lines, and I get this situation here where it crosses out and this is not true, that means the lines are parallel. In other words, they'll never touch, so there is no solution. Number 12, they ask us, which of those points satisfy the function? In other words, which of those are a solution? In other words, which of those are on this line? How do I do that? Well, quickest way is just to plug them in. So I'll plug 14 where y goes, because that's y, and 0 where x goes, and I'll simplify. 14 does not equal negative 14, so don't pick A. B, I plug in y where y goes, x where x goes. Now, when I simplify this, negative 9 minus 14, look, I'm going to add two negatives. I know that's going to be a negative answer, so I'm not even going to continue, because this one's positive, this answer's negative. I'm going to save some time and say, forget about that one, let me move on. That won't work. C, I'm going to plug in y here, x here into my equation they gave me, and simplify. Now, this is negative, so it might work, so I'm going to keep going. I'm going to do my rule for subtraction. I'm going to do teams here. Negative 9 and negative 14 is negative 23. I see that's true, so this is the answer. This one is a solution to that equation. It satisfies the function, in other words. It's on the line, on the graph of the line. Now, if I check D and I plug it in, I know that if I have negative 14 here, and negative 14 and positive 9, there's no way that can be the same, so I can stop. I know that doesn't work. For number 13, we have to say which function has the greatest rate of change. Well, the first one is an equation. It's in slope-intercept form. The slope has to be whatever's in front of x. Since the y was isolated already, the slope is 12. Second one, I know the same thing. Slope has to be negative 7. It's what's in front of x. Third one, I pick 2 points. I'm going to pick small numbers, positive numbers. Now, I'm going to go y minus y. I'm going to start on the right this time to try to avoid negatives. But since I started on the right, I got to start on the right with my x's on the bottom too. Even if it ends up giving me negatives, I got to still keep the same order. So I go y minus y over x minus x. 6 take away 2 is 4. 3 take away 1 is 2. 4 divided by 2 is 2. The slope for this is 2. The rate of change is 2. That's not as great as negative 7. Remember, we look at the absolute value when we're talking about rates of change, right? We pretend they're all positive. That's not as great as 12. So let's check D. D is a word problem, and it says there's $25 per month. Every month they're going to charge $25. The other one's a one-time fee. That's the y-intercept. So the slope is 25. 25 is a greater rate of change than all those. That's my answer. 14, we have to say with this equation y equals negative 6x plus 8. What's the appearance of that? Well, I know it's a line because y and x are to the first power. Nothing fancy, right? No x cubes, no absolute value of y. So that means it's a line. And I look at the slope because it's in slope-intercept form. The coefficient's negative 6. The number in front of x is negative 6. So that has to be my slope. So that's just going to be a line sloping downward. That's the description of that. 15 says a string reaches from the top of a 19-foot pole, so this is straight up and down perpendicular. That's 19. Down 9 feet from the base, so this distance is 9. How long is the string? We have Pythagorean theorem. 19 squared plus 9 squared is c squared. Do 19 times 19. You should have got 361. 9 times 9 is 81. We have to add these two. Now, this is c squared. I need c, so I take the square root of both sides. Now, I got to check to make sure this is not a perfect square. So I just narrow it down. Remember we did that a bunch in the beginning of the year? 20 times 20 is 400. That's close. I try 21 times 21. That's 441. I can see this is not going to be a perfect square. So my answer is an irrational number. This is an exact answer. I'm not going to estimate because the directions told me to give an exact answer. 17, we got to give the distance between those 2 points on the graph. Well, what I do is I'm sorry, I skipped 16, didn't I? Let me back it up. So 16 says a circle is translated according to the rule x plus 6, y minus 1. So this is a slide. Whenever something slides, it doesn't change size. So the only answer is A, because the other ones say that they're getting shorter or longer, but that doesn't happen unless it's a dilation. 17, we got 2 points. I take the coordinates for the 2 points they gave me, and if I got to find the distance, I do the distance formula. So the distance formula is x minus x squared plus y minus y squared, and put that all underneath the square root. So I plug my numbers in. Remember, these are x's and these are y's over here. I do my rule for subtraction first and add those up. I end up with this, and then I can stop. Because they didn't ask me to finish it, they just asked me which expression below is the same. And the only one that's the same as what I did is D. It has to be D. 18, they give us 2 transformations. First one says x plus 4, y plus 4. That's a slide to the right 4 and up 4. The second one says 4x and 4y. That's a dilation with the scale factor 4. In other words, everything's getting 4 times bigger. So if I read my options to say which of the statements are true, number 1 says this. Follow along with me on your paper there. Read it with me. It says the image in transformation 1 has an area that is 4 times greater than the image in transformation 2. That's not true. Transformation 1 didn't change. Transformation 2 is 4 times bigger. So don't pick A. B says this. The image in transformation 2 moves the original triangle 4 units in each direction. Okay. Well, no, our center of dilation is the origin. Okay. So it won't go exactly 4 units in each direction. The only way that's even possible is if it was like a rectangle and it was the center of the image was perfectly centered right on the origin, but that's just don't pick B, okay? Because that's not we're talking about a triangle. C, all but one of the vertices in the image of transformation 1 is different from the original. Well, no, that's not true because look, we're going to the right 4 and up 4, so all of the coordinates are going to change. So C doesn't work. And D, the image in transformation 2 has a perimeter 4 times greater than transformation 1. Remember, we learned this in class, that all the lengths and the coordinates and the distance to the point of dilation and even the perimeters increase by whatever the scale factor is. And the scale factor is 4 because that's the coefficient, so the answer is D. Alright, now the only one that doesn't work for is area, right? The area increases by the scale factor squared. Okay, but this one isn't even that complicated. It's just asking perimeter, which is straightforward. Scale factor is 4. Perimeter will be 4 times bigger as well. Okay, so that's the answer. And we're looking at 19. 19, we have a triangle. What's true about all triangles is that if I add all the angles up, they always equal 180. That's called the Triangle Sum Theorem. So one of my angles is 43. The other one's x. The other one's 49. Together, add them up, should equal 180. So if I got to figure out what x is, I just solve this equation. Combine my like terms, isolate the variable, and I see that the missing angle is 88 degrees. But now we have to classify this triangle. Well, if I have a triangle where all of the angles are acute, that's called an acute angle. So there's my answer for 19. Okay, 20, we have this diagram here. We got to find x. Now, this right here is a vertical angle to this, and we learned in class that vertical angles are congruent. So this has to be 140. So now we have the same problem that we just did. Add the 3 up. Combine my like terms, isolate the variable, and x has to be 18 degrees. Alright, 8th graders, I hope that helped you guys out.